There are 6 exam objectives known as domains covered in the CompTIA IT Fundamentals exam. This is domain 1 of 6. Within domain 1 are 6 sections. Let's start with the first section, IT Concepts and Terminology. You'll find that once you enter the world of computers, you'll have to expand your vocabulary. Included in your new vocabulary will be many acronyms. An acronym is a word created by taking the first letter of each word of a given subject, title, organization, etc. For example, many of us have heard of NASA. NASA is an acronym for National Aeronautics and Space Administration, but we'll get into acronyms later. Let's start our vocabulary words with notational systems. What is meant by notational systems? In this case, it simply means determining what symbols are being used to represent numbers. We'll start with the symbols we all grew up with. We learned to count in decimal. Decimal then is known as a base 10 system. You'll see that the symbols used in decimal somewhat repeat themselves every 10 units. I've entered these numbers into an Excel spreadsheet. This is how we learn to count, 1 through 10. After 10, the numbers will repeat themselves in the ones column. So no matter where we start, whether it's 1, 11, 21, or even 71, for the next 10 numbers, they will repeat themselves. So we're going to have 11 through 20, but you'll notice in the ones column, it is once again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When we get to 21, again, the ones place repeat themselves until we get to 0. And even when we go to 71, the ones place will repeat themselves. If you look at these columns, the ones place, they are all 1, 2, 3, 4, 5, all the way to 10. I've set up an Excel spreadsheet with 3 rows. The top row represents a bit position. The second row represents the bits. The third row represents the value that's assigned to each bit. 8 bits is equal to 1 byte. Each cell is representing a bit. Therefore, I'm actually showing you a representation of 1 byte, which is 8 bits. If you notice, each bit has an assigned value that doubles as we move from right to left. I've also set up this spreadsheet so that when we turn a bit value on, it raises the value, or it shows the value of the sum of those turned on bits in cell C8. So for example, in order to turn on bit number 2, which has a value of 64, I'm going to put a 1 in cell D5. If I want to turn on bit number 4, which has a value of 16, I give it a 1. So 64 plus 16 is 80. So currently this byte has a value of 80. If the bit is to remain turned off, we need to give it values of 0. So if I continue to turn off values 6 and 7, but I turn on bit number 8, this byte has a value of 81 because 64 plus 16 plus 1 is 81. So our very first binary number that we're learning is 01010001, which is a decimal number of 81. We've done our first conversion. Let's clear our byte. So we're going to take all these ones and zeros and we're going to clear them. Let's convert a number, let's do 133. Okay. So if you've noticed, I have set it up so that cell B8 indicates what number is left after we perform a few subtractions. So the idea of converting a decimal number into binary is to turn on the bit closest to the number bit that has a value closest to the number without going over. So the highest value we have on our bits is bit number 1, which has a value of 128. So what we're going to do is we're going to turn on that bit number 1, which has a value of 128. Now what we're going to do is we're going to subtract 128 from 133, and that leaves us a value of 5. So we need to turn on the bit closest to 5 without going over. Well, we can't turn on 8, that's higher than 5, but we can turn on bit number 6, which has a value of 4. So when we turn that bit on and we subtract that value of 4, that leaves us with a value of 1. So what we've done is we've taken 133, we've subtracted 128, and then we've subtracted 4, which leaves us a 1. So the closest bit with a value of 1, that's closest to 1 without going over, is actually bit number 8, which has a value of 1. So when we subtract 1 from an additional 1 from what we've already subtracted, so 133 minus 128 minus 4 minus 1 gives us 0. So we've turned on the bits with the value of 128, the bit value of 4, and the bit value of 1, which is 3. Therefore, 133 is the number that we have translated into binary. The rest of the bits we are going to turn off. Our decimal number 133 has been converted into binary, which would be 1 0 0 0 0 1 0 1.